Okay, welcome to the second video in our series on the AQA Level 2 Further Mathematics. Here we have 5 random questions from a Paper 1 non-calculator paper. Okay, first question. Here we have a parabola curve with an equation y equals x minus 2x minus 3. Okay, and we can see straight away it's been factorized already. So we know that this must be the point with an x-coordinate of 2 and this with an x-coordinate of 3 at Q. Okay, we need to find the gradients of the curve at P and Q and show that they are perpendicular to each other. The tangents, that is, the straight lines that go through P and Q. So what we're looking for is these two straight lines here. So this one would go through P roughly like that. Okay, and this one would go through Q roughly there. And what we're trying to show is that those two lines are at 90 degrees to each other if it were drawn to scale. Okay, now we need to differentiate to find the gradient, but before we do that we need to rearrange this or multiply it out to give us y equals x squared minus 5x plus 6. And from that we can say that dy by dx, the gradient function, is therefore simply going to be 2x minus 5. Okay, and when we go to the point P, we know that x is 2. So at the point P, dy by dx is equal to 2 lots of 2 minus 5, which is negative 1. And at the point Q, we know that dy by dx is going to be 2 lots of 3 minus 5. Okay, which is 1. And if you multiply the two gradients together, you get minus 1. And that means the lines are perpendicular, because a perpendicular line has a gradient that is the negative reciprocal of the other. All right, and so all you need to do now is just say therefore perpendicular. Okay, and that's it. Okay, next question. Okay, so we have to prove that that statement is always a multiple of 4, given that n is an integer. Well, there's quite a few marks for this, and if nothing else, you start just by multiplying out the brackets. So we have here n squared plus 4n plus 4 from the first bracket, and from the second bracket we have n squared plus 2n plus 1, and we also have our minus 1 there as well. Okay, and that is then simplified to give us n squared 2n squared plus 6n plus 4. Okay, and we can take out a factor of 2. Okay, but not a factor of 4, not immediately anyway. So it gives us 2 lots of n squared plus 3n plus 2. Okay, now all we can conclude from that is that it's even. We can't conclude from that it's a multiple of 4. But we can take it a little bit further, because if you look carefully at that quadratic in the brackets, you've got 2 lots of n plus 1 times n plus 2. Okay, and now what you have is 2 consecutive integers. Okay, now the product of 2 consecutive integers is always even, because if that's even, this is odd, and if that's odd, that's even. So you've got basically 2 times an even times an odd. Okay, and because of that you can conclude that because it has two even factors, then it must be a multiple of 4. And that's how you finish it off, and I'll just write that statement. I've already typed it out there. So 2 even factors, therefore result is a multiple of 4, and that will get you the marks. Okay, next question. This is about using the factor theorem. Okay, so if we call this function here f of x, okay, then if x minus 5 is a factor of f of x, then f of 5 equals 0. Okay, so we just need to see what f of 5 is. So f of 5 is simply going to be 5 cubed, okay, minus 6 times 5 squared, plus 5 times a, okay, and minus 20. And we know that for the factor theorem that would be equal to 0, because that would mean there's no remainder, you see. So what I do now is just rearrange that to find a. So it's actually quite easy. We've got 125. Okay, we're taking away 6 times 25, which is 150. So that's minus 25 plus 5a. Okay, now that equals 20. If I add that 20, I'm now going to add the 25 that I get from by adding 25 to both sides. So I get 5a equals 45. Okay, and therefore a must be equal to 9. And that's all we had to do. Okay, next question. This is a triangle that isn't obviously right-angled, and we've got to find that, or show rather, that angle CAB is 60 degrees. Now remember, this is a non-calculator paper, so this is about using the cosine rule. All right, now I'm just going to call this angle here theta, because that's the angle we've got to find and then show that, or find the cosine of theta and then show that it's 60 degrees. Okay, so now we use the cosine rule, and we say that this squared equals that squared plus that squared minus 2 lots of that times the cosine of theta. So it looks like this, doesn't it? 2 root 6 squared, I'll just write it in full first of all, equals, well, it's 3 plus root 5, okay, squared, plus 3 minus root 5 squared, minus 2 lots of 3 plus root 5 times 3 minus root 5. Okay, and times the cosine of the angle between them, which is the cosine of theta. Okay, now we have to show all these steps because it says we've got to show that that angle is 60. We can't just take any shortcuts. Well, the first part is easy enough. You've got 4 times 6, which is 24. So we're saying that 24 is equal to this. Now, if you do this in your head, you're going to have 3 squared plus 5, root 5 times root 5 is 5, plus 6 root 5. So you've got 9 plus 6 root 5, okay, plus 5. And similarly, from the second bracket, you're going to have 9 minus 6 root 5 plus 5. Okay, because minus times a minus is plus. And then you're going to have this. Now, when you multiply a pair like this, where one's a plus and one's a minus, you lose the irrational part. So you'll have 3 times 3 is 9. The inner and outer terms cancel, and you'll have 9, and you'll have root 5 times root 5, which is 5, and it'll be 9 minus 5, which is 4. So it's 2 lots of 4, okay, times the cos of theta. So the next step is just to simplify this further. So I've got 24. Now the plus 6 root 5 and the minus 6 root 5 cancel. So I've got 24 equals 9 plus 5 plus 9 plus 5, which is 28, minus 8 cos theta. Okay, now if I add 8 cos theta to both sides and take away 24, that will give me that 8 cos theta equals, so I'm adding 8 cos theta to the left and taking 24 away will give me 4, which means that cos theta is a half. Okay, cos theta is 4 over 8, which is a half, and the inverse cosine of a half is 60 degrees. Okay, and you can just quote that because you're supposed to know that. So theta equals 60 degrees. Okay, and just to quickly remind you where that comes from, if you took a right-angled an equilateral triangle, I'll show you this very quickly. So if you have a triangle that's equilateral, let me just find one, and if you split it down the middle, okay, let me show you this. Okay, so this is how I know that the cos of 60 degrees is a half. So if I make the sides of the triangle 2 and 2, and this is now going to be 1 and 1 because I've split it down the middle. Okay, there's my 90 degrees. We know that's 60 degrees there because it's an equilateral triangle, and the cosine of 60 is the adjacent over the hypotenuse, 1 over 2. Okay, so that shows that cos 60 is a half. So theta is 60 degrees. Okay, and the next question. Now this is about matrices and transformations. Now you're supposed to know these and learn them. So A is a rotation through 90 degrees clockwise about the origin. Okay, so what this comes from, the rotation. The general rotation matrix is actually this. Okay, and it's a good idea to learn this because this will help you in answering the questions. So it's a matrix where theta is the angle of rotation anti-clockwise, okay, and it's cos theta minus sine theta, cos theta. Okay, so they're the 4 elements of the matrix for a rotation. So in general, but if you're dealing with a 90 degree anti-clockwise rotation, then the cos of 90, okay, is 0, and the sine of 90 is 1. So it's 0 minus 1. The sine of 90 is 1 and cos is 0. So that matrix there is the matrix for a rotation of 90 degrees anti-clockwise. Okay, so that's the matrix they're calling A. Okay. Now the reflection in the x-axis is the matrix B. Okay, and that is going to be 1, 0, 0, minus 1. Okay, it's easy to test these out. Okay, if you just take a point and multiply it by that matrix, you'll see that what happens is its x coordinate stays same, but the y coordinate becomes negative. Okay, so that's a reflection in the x-axis. So that's the matrix they're calling B. And now it's saying if you do operation C, it's a transformation of A followed by a transformation of B. Now remember, to do this you need to put the matrices in the reverse order. So the A goes closest to the point that you're working on, and the B in front of it. Okay, so you write down the matrix B times A. Okay, so BA is equal to 1, 0, 0 minus 1 multiplied by 0 minus 1, 1, 0. Okay, and if you carry that out, you get 1 times 0 is 0, 0 times 1 is 0. Okay, 1 times minus 1 is minus 1, and 0 times 0 is 0, so that's minus 1. And then you have 0 times 0 is 0, minus 1 times 1 is minus 1, and then 0 there and 0 there, so that's 0. Okay, and that matrix there represents a reflection in the line y equals minus x. Okay, so reflection, so that's equal to C. Okay, so C is that, which is that, and then you just need to say that C is a reflection in y equals minus x. Okay, and you are supposed to learn those matrices. Okay, and that's it.